The last thing we need to talk about is the power property of equality. And this looks kind of complicated. It's going to be much simpler if you just think about it. For any real number b greater than 0 and b not equal to 1, b raised to the x and b raised to the y is true only if x equals y. These are only equal if their exponents are equal. Well, that makes sense, because if I think about it, if I had 5 raised to the second equals 5 raised to the third, obviously that wouldn't be true because I can't raise 5 to the second and 5 to the third and get the same thing. The only way that would be true is if I had 5 raised to the second equals 5 raised to the second. Now the reason it's not allowed to equal 1, because we know 1 raised to the second power is still 1, 1 raised to the 200th power is still equal to 1. So this will not be true if your base is 1, but for anything else it would work. So if I had 5 raised to the x and 5 raised to the third power, the only way that could be true is if x is 3. So 5 raised to the third equals 5 raised to the third. It's got to be the same thing on each side. You've got to be able to get the same exponent. And then if n equals 1/2, then 4 raised to the n power would have to be the same thing as 4 raised to the 1/2 power. Okay, it kind of makes sense. You just have to have the same exponent on each side if you have the same base. Otherwise, it will not be equal. So we want to solve these equations. What you're going to have to do is make them so they turn into the same base. Well, I could either turn 6 into 216. That doesn't necessarily sound very easy to me. Or I can try to turn 216 into 6. Well, you may not know this off the top of your head, but 216 is just 6 raised to the third power. So I'm just going to rewrite that on the right side. 216 is 6 raised to the third power. Okay? And that is the one thing that will make these tricky. If you don't know what it is, raised to a certain power, these problems can be a little tricky. But once you do enough of them, it becomes easier to remember which numbers raised to which powers are common. So now I have 6 raised to the x equals 6 raised to the third power. Well, how could these two things be equal? The only way 6 raised to the x and 6 raised to the third can be equal is if their exponents are equal. So I'm going to take the exponents and set them equal to each other and solve that equation. Well, I get x equals 3. This equation is already solved. We know x has to equal 3. We're done. If we look at the second one, it's a little more complicated. We've got 25 raised to the x minus 1 equals 5. Two different ways you could do this. We could try to turn 25 into 5 or 5 into 25. Okay, I'm going to turn 25 into 5 because I know 25 is just 5 squared. So I know instead of writing 25, I can write 5 raised to the second power. Make sure to put this x minus 1 in parentheses. So I get 5 to the second power times the x minus 1. Since it started out with that x minus 1, you got to put it in parentheses when you change it, equals 5. Well, 5 has no exponent, so is it 0? No, we know if there's not an exponent, there's really a 1 there, so it's 5 raised to the first power. In order for 5 raised to the 2x minus 1 to equal 5 raised to the first, their exponents have to be the same thing. So I know, since their exponents have to be the same, that 2 times the quantity of x minus 1 has to equal 1. And now I just solve this equation. First step is to distribute. We get 2x minus 2 equals 1. Then I'm going to add 2 to each side. I get 2x equals 3. Divide each side by 2. X equals 3 over 2. So the only way these two will be equal is if x equals 3 raised to the 1/2. And this actually would be kind of easy to check. Plug in 3/2 for x. 3/2 minus 1 gives me 1/2. And we know 25 raised to the 1/2 would be the square root of 25, which does equal 5. Okay? Biggest thing, make sure the bases look the same. Once the bases look the same, we can set their exponents equal to each other, and then we can solve for x. And that's all there is for this section. Go ahead and let me know if you have any questions.